Alright, let's look at the homework 5.2, 5.3, problem number 15. Alright, a fruit grower can use two types of fertilizer in his orange grove, brand A or brand B. The amounts in pounds of nitrogen, phosphoric acid, and chloride in a bag of each brand are given in the table. Tests indicate that the grove needs at least 1,050 pounds of phosphoric acid and at most 40 pounds of chloride. Right? Answer part A and part B below. If the grower wants to maximize the amount of nitrogen added to the grove, how many bags of each mix should be used? How much nitrogen will be added? Alright, so let's answer that question. So I'm gonna bring this so that I can write. Alright, so let's see. So I'm gonna use X for the brand A and Y for brand B. Alright, so what we want to do is we want to maximize the nitrogen. I'm gonna call it since it's nitrogen, I'm gonna call it N. Right, amount of nitrogen is going to be, alright, so 5x plus 8y, right? Alright, then it says that we have to have at least 1,050 pounds of phosphoric acid. So, which means that, let's see, phosphoric acid, the total would be, so it's going to be subject to. Alright, so here is the first constraint. So the amount of phosphoric acid would be 3x plus 3y. And this has to be less than or equal to 1,050, right? Because it was, let's see, it says, actually, it says at least. So, actually, I have the wrong inequality. At least means it has to be greater than or equal to 1,050 pounds. All right. Then another condition is that we have to say at most 400 pounds of chloride. So this says at most, so it's going to be less than equal to. So chloride would be 2x plus 1y. Right? So is at most, so less than or equal to 400. And of course, it's realistically, we shouldn't talk about the negative, pounds of fertilizer. So we have that. All right, number of bags. Actually, X and Y are number of bags. Sorry about that. So number of bags of, let's see, maybe I should say fertilizer in the each bag. Okay, so it's X and Y are number of bags. All right, so this is the linear programming, and we're trying to solve this linear programming problem. All right, so let's try to use the GeoGebra here again. So I'm cheating a little bit. All right, so constraints. So we want x to be greater than or equal to 0. Got that. And y is greater than or equal to 0. Got that. So those are the non-negative constraints. All right, so first inequality is 3x plus 3y is greater than or equal to 1,050. Right, that's actually a pretty big number. Right, so I'm going to actually zoom out to be able to see this. Zoom out, zoom out, zoom out, zoom out, zoom out, zoom out. All right, now we're starting to see it. All right, zoom out. All right, so this is the first inequality. All right, the other inequality would be 2x plus y is less than or equal to 400, right? So let's put 2x plus y is less than or equal to 400, right? Then put the equality there and hit enter. Right? Then you can see that it's actually the region. I'm gonna zoom in a little bit. So this would be the region. Oops, sorry. Right, go here and right. I'm gonna zoom in here. Right? Maybe one more. All right. So this is the solution region. Right? So this triangular region is the solution region. And what we want to do is we want to maximize n. So I'm going to type in right here 5x plus 8y is going to be equal to, let's see, n might not work because it might, let's see, let's try n, see if it works. Alright, I guess so let's create a slider, right? Then I'm gonna just click on it and go to object property. Alright, then I'm gonna just start, so this n value is going to be, so it's an amount of nitrogen, right? So it's going to be, let's see, I'll put 10,000 again. It doesn't have to be probably that big, and put 1 here. Alright, then here. Alright, so here, if I move this slider up and down, see if we can see the line here. Starting to see the line. Alright, so this is the nitrogen function. Alright, and what we want to do is we want to maximize the amount of nitrogen. So we slide it up as much as we can. Alright, then you can see that the highest you can go without going out of this triangular shaded region would be somewhere around there. Right? Let's say I'm gonna zoom in to see if I, oops, sorry, I put the wrong thing there, and click here, click here, click here. Right? Actually, I'm missing a little bit right here, so I'm gonna actually go to the slider. I'm gonna go up a bit more. Right? Maybe something like that, and I'm gonna just make sure I'm hitting the right place. Right? Looks like I'm right on the intersection. Right? All right. So it looks like the maximum amount of nitrogen is 3,200. So I'm gonna go down here, and let's see, max. Well, actually, we have to find the amount of bags, right? So you can, if you go here, right? So it looks like this is on the y-axis, which means that the brand A bag is going to be 0. X is 0. And y is 400. So here, 0 here, y is 400. All right, then, right, check the answer. All right, we got that. And then a maximum amount, we just found that to be 3,200, which is simply multiplying 8 times 400 bags, right? So 8 times 400, so 3,200. Right, so we check the answer. We got that. Alright, then if the grower wants to minimize the amount of nitrogen added to the grove, how many bags of each mix should be used, and how much nitrogen will be added? Right, this is pretty easy since all the work is pretty much done, and we have to actually zoom out a bit, so we can see the lower end. So let's see, let's go here and zoom in, zoom in, zoom in, zoom in, zoom in, zoom in. All right, I'm beginning to see. Yep. All right. So what we're going to do is, since we want to minimize, we're going to actually push the line down. So you can see that this is a nitrogen function, and we want to push it down as far as we can without going out of the shaded triangular shaded region here. So solution set. Alright, so something like that, but I'm going to go in and zoom in and see if we are going through the right spot there. Alright. Alright, actually we need to go a little bit further. You can see that, right? So I'm going to, we can actually move down a little bit more. Alright, so right there, right? So you can see that what is the point there? I have to actually find it. So I'm going to use this tool here. So I'm going to click on that, right? So that point is 50, 30. So you're going to use 50 bags of brand A, and what was the other one? I forgot the 300 bags of the brand B to minimize the amount of nitrogen, right? And the minimum value would be, and the Jupyter already tells you, 2650. So we put 2650 pounds and check the answer. All right, we got that. All right, that's it. I hope that this was clear.